Welcome to the Valley Today, a public service presentation of the good folks at KAIL-TV. As fresh water becomes more scarce, we need to come up with alternatives for potable water. In steps Biofiltro. They take wastewater and treat it for reuse. Join us as we visit with Sanjor Taromi of Biofiltro, up next on the Valley Today. And welcome to the Valley Today at Fresno State with Sanjor Taromi with Biofiltro. And Sanjor, thanks for being on our show.
Pleasure. Glad to be here.
Tell us what Biofiltro is all about.
Biofiltro is a company originating from the Latin American country of Chile. The technology that we have was developed in 1994 by Alex Vilagro, our founder. And essentially we have a wastewater treatment device that you see here behind us. It's a biological filter that uses earthworms and wood shavings and the castings to process wastewater. We process wastewater in the food processing industry, in the dairy industry, and sewage as well. We have about 100 installations worldwide, and the decision was made to come to the Central Valley, California because of the vast amount of wastewater that's produced here. We've been here since August of 2013. And now we're here at Fresno State campus conducting this dairy trial so that other dairymen and other food processing people can come and see our technology in operation.
So you're processing animal waste,
Correct.
Essentially, and food processing waste.
Yes.
And then what other waste?
Sewage.
And sewage.
Municipal waste, yes.
But primarily because of the higher population now, it's you really probably want to treat sewage, right? Human sewage?
Well, we do all of them. So we're active in all the fields. Here, the dairy industry is very important because of the nitrogen contamination of the groundwater, and our system can take out the excess nitrogen. So that was one of the biggest reasons coming to the valley. There's 1,500 dairies, and many of them really need a system like this to take the nitrogen out of the water.
Now, can you recover the nitrogen so that it can be reused back in the farming application?
The nitrogen is converted by the earthworms to worm castings, which is their manure, and it's a very valuable organic fertilizer. And the nitrogen is now in a much more bioavailable form, so it's captured, and the dairyman can reapply that to his fields or to his orchards.
Wow.
To grow crops.
So what kind of worms do we have here?
The worms that we have is the California redworm. It's a compost worm. It's a common worm in California. It manifests in organic material.
Yeah.
So it kind of, you won't find it in the soil. When it rains, it's not the one that pops up from the ground.
Okay.
It's actually, you'll find it in cow manure and many farmers. I myself, before I joined Biofiltro, was a worm farmer. Okay. And that's the type of worm that we
So you
use.
Were farming worms to resell for fish bait, or?
Yeah, you resold the worms typically for home composters, fish bait as well if you got big enough, but mainly the castings for the viticulture industry.
How many worms do you have in this application?
We have
millions?
No. Right now, since we inoculated maybe a month ago, we have tens of thousands. But in due time, it'll reach the
Now,
millions
what do you
phase.
mean you inoculated them?
When you put worms into an organic material, the term we use is inoculation.
Oh, okay. So that can conceivably, it could, if depending on how heavy your sewage or your waste treatment is, that could conceivably kill them too, right?
No, the only thing that can kill the worms is something that's below the pH of 5 and above a pH of 8. So you could put chemicals into here, but as long as the pH is neutral, it's not going to kill the worms. And we size the system perfectly for the gallons per day that's discharged into the system, as well as the quality of the water coming
So how long has this technology been embraced?
Well, as I said, the technology was invented in 1994 by Alex Vilagro, and we have 100 installations worldwide right now. We have 80 facilities in Chile, and we have several in New Zealand, Spain, Mexico, and Brazil. Okay. And now we have 3 pilot projects here in California, one here at Fresno State Dairy, one at a tomato processing facility in Fireball, and one at the city of Fireball sewage treatment plant.
So can you treat all the sewage that, I guess it just depends on the size of the treatment plant.
We can do millions and millions of gallons. Mm-hmm. This system that you see here would just be scaled larger in that case. Yeah. So we have no limit to our capacity. As long as the land is there, we can build and treat any amount of volume.
And you had mentioned before we'd rolled tape that you can take this wastewater and get it back as potable water, right?
Yes, we can. We're considered a secondary treatment system, so we take out a lot of contaminants called BOD, biochemical oxygen demand, and total suspended solids. These are the kind of organic contaminants that can gunk up pipes and things like that. So once we treat that and take out those contaminants, tertiary treatment, which is either chlorine or UV or ozone, can do a much better job taking out all the bacteria and all the viruses that could be within it. And then yes, you could have potable water.
So in the human waste now, there's a new thing they're talking about, antibiotics.
Yes.
Because everybody takes antibiotics to heal themselves from whatever illness they have.
Yes.
And that's in our sewage water supply now. Not only from humans, but also from animals. And
Yes.
how are you able to treat that?
Well, we've never looked at that before. It's never been a requirement, but we know conventional systems don't do anything in terms of antibiotics or the medicines that people consume. Worms have shown to bioaccumulate heavy metals, pesticides. They've shown to bioaccumulate in their tissues a lot of inorganic material. So in our tests and in our pilot projects, we'll start testing for things like antibiotics and medicines so we can see if there is any change.
Okay.
But we feel that there may be some potential there for us to take out at least a certain degree of those contaminants.
So with this system here, how much water are you able to treat? Is it on a daily basis? How do you measure how much water you treat?
This is a day, so we size this system. Fresno State Dairy discharges about 25,000 gallons a day. So we're charging about 2,700 gallons.
Okay.
So we've sized that system for that, and we achieve a 97% reduction on the key indicators of BOD and TSS. So that's
Okay.
how we size our system. And so we've built it to demonstrate the reductions we can get. And you just scale this bigger and
Right.
for a bigger flow. So
You figure it's X amount of size per X amount of animals. Is that correct?
in that case, because every cow produces about 80 to 100 gallons, so then we make that calculation.
Per day?
Per day.
Oh my God! You
It's
mean
a
they're
lot
putting
of
out
water.
they're putting out that much waste a day?
Well, they're washing them, they're
I see.
drinking
Okay.
them, they're cleaning.
So beyond the urination and
Yes.
beyond the fecal matter, they're washing them and cleaning them before they go
Yes.
for milking.
And they're using the flush lanes, and they're using water to push the manure down the flush lanes and into the lagoons that they currently use.
You know, there's a lot of people that have been upset with the cattle with the dairy industry because they say they're using too much water, too much
Yes.
fresh water.
Yes. And so where we could help with that is we treat the wastewater so they can reuse it down their flush lanes. Right now they're adding a lot of fresh water to their dirty water to flush the lanes.
Yeah.
So we can increase the efficiency of using that water. We can also, right now they're using flood irrigation to take their wastewater and irrigate alfalfa crops. Well, we take out a lot of those solids, so then maybe now they can use center pivot or they could use subsurface drip. So we allow them, we give a dairyman more options to be able to use their water by using more conservation measures.
Yeah.
So we can definitely in some ways help them reduce the amount of fresh water they're
And
using
you
on a
can
day-by-day
clean the
basis.
water depending on what the end application is going to be, whether
Correct.
it's going to be put on for feed for animals or whether it's also going to be put on crops that humans are going to consume, right?
Correct. Because our technology is so derived from Mother Nature and it's pretty basic, we can lower a lot of costs compared to conventional technology. So dairies would not be able to afford a conventional system like activated sludge, but they can afford a system like this.
So what does a common dairy do with the wastewater now?
Well, common dairy, whereas food processors and sewage treatment plants have to treat the water and they have the money to treat the water, dairies they'll have several lagoons and they'll do solid separation. So they take out a lot of the solids and then it goes out to the lagoons, and sometimes they capture methane if they're doing that, or the most basic thing is after the lagoons, after the solid separation, they flood irrigate acres, hundreds of acres of land where they're growing food crops for their alfalfa and corn for their animals.
And that's nitrogen rich, right?
It's nitrogen rich, but the problem is there's excess nitrogen. So the plants are taking a certain amount, the roots are taking up a certain amount, but the excess is going to the groundwater. So that's why they buy more and more land So they say if they spread it out more and more, less of that is getting to the groundwater.
I see.
So what we allow is, because we're scrubbing out that excess nitrogen here, the dairyman doesn't need to farm as much land.
I see.
They can reduce the number. So there's those dairies that are landlocked right now. They can reduce the number of acreage they have and even increase their cow population, because now they're not relying on the land as their disposal method. They're relying on the biofiltro system.
So you have these worms are putting out castings, and
Yes.
so how much can they put out?
Well, it depends on the wastewater coming in, but with dairies, we harvest those castings every 12 to 18 months. And it's per square foot, there's a certain amount of production. So we take out about the first 6-inch layer every year.
So where are the animals living in this biofiltro here?
Right now, they're from here to right here.
Okay, and so all below this is all just filtration?
Yes, it's more wood shavings and rock, and then a pocket of air that connects to the pipes that you see right here. So there's a passive airflow system.
Okay, so the water's getting sprayed on top, it's filtering through, the animals are getting to the water, and they're feeding on that, right?
Yes. They're feeding on the organic material that's in it.
So is there some solids in this water?
Yes, there is, but very little. We've taken out, you see the solid separators, we've taken out most of the solids.
I got you. Okay, very interesting. Yeah. This is very interesting. So you think this will be embraced by most dairies here on the planet?
Well, dairies are beginning to embrace it. Food processors are beginning to embrace it. This is a biological system that's very straightforward. It makes sense. You don't need the most skilled people to operate it. Yeah. So we are getting embraced here in the valley, and this is a great place to be.
But more than likely, you probably have a chemical background, right? Don't you have a chemistry background?
No,
oh, you
chemistry.
Don't?
I'm an entrepreneur.
Oh, okay.
I'm an entrepreneur. I was a worm farmer in the past. We have engineers. We don't use any chemistry here.
Okay.
No chemicals. The worms are the chemists.
Well,
here.
you are checking the pH balance here.
Oh, of course.
Yeah, right.
pH is the most that we'll do, and that's before and after this.
This is absolutely fascinating, Sanjor. You have a sample for us. You want to show us some samples?
Yeah. So this is the before and after.
Which one's the before?
This is the before. So this is typically what goes out to dairy lagoons and festers and sits, and when you smell the odor coming from dairies, it's from this stuff going out into the lagoons.
So is there a lot of methane in that also?
Yeah, a lot
of captured methane in the liquid?
In this one, yes.
Yeah, okay.
A lot of methane waiting to be released into the lagoons.
So do we do a smell test?
Let's do a smell test.
Ooh, man, yeah.
It's pretty bad, huh?
It smells pretty bad.
So what we do is we don't let the wastewater go out into those lagoons. We capture it immediately as it comes to the flush lanes. And this is a little bit darker than usual because of the tannins from the wood, so it actually clears up a little bit. But
okay, so the tannins are coming from the wood chips.
Exactly. Why don't you take a smell?
I don't smell anything.
He doesn't smell anything. So the worms...
And I got a pretty good nose.
He's got a good nose. The worms have eliminated the odor. So essentially when we implement at dairies, the odor is going to almost be eliminated.
So I would assume that this was waste product, but this is tannins.
This is tannins.
Yeah, okay.
So this isn't manure left over from actually this water. This is actually the wood tannins that have made it this color.
Wow, that's very interesting. So this technology came out of Chile from Alex, what was the gentleman's last
Alex
name?
Villagra, he's somewhere here rummaging in the back. So Alex, along with his university professor, developed at the University of Santiago in Chile, developed this technology. Alex, and it was for sewage treatment. Alex
for human sewage treatment.
For human sewage treatment. Then Alex took that technology and developed it even further, and essentially created the BIDA system, and he went on to really take off in the food processing industry and then into the dairy as well. Dairy is not as big in Chile as it is in New Zealand. That's why a big company like Fonterra picked up Alex and took him all the way out to New Zealand. Now, in Chile, one of our best applications is actually rural communities. There's many little rural communities that have to have water trucked in, and the wastewater that they have isn't even treated at all, so it's contaminating the groundwater. So our system was very applicable, where we would go and build this system, and literally the townspeople would operate the technology. And now the government of Chile is actually funding and support the proliferation of our technology to these rural communities out there.
So these animals that you've got in this Biofiltro system, can you use the animals for other, can you harvest them for for fishermen? Can you harvest them for other applications?
Yeah, so worms, when they're in the right environment, and cow manure is a great environment for them, is they double in number every 60 days.
Wow.
So when we go out every year to harvest the castings, we also harvest the worms and we separate them.
So how do you separate the castings from the wood and all that?
There's a trommel screen.
Uh-huh.
So we go out, we physically, manually take out the castings, the top layer. Sometimes we can use a backhoe to do it as well.
So you've got to be careful when you're harvesting that not to get the animals, right?
No, we get the animals in there as well.
Oh, I
so
see.
the animals are in the castings, we get them all out. We use a trommel screen, which uses the force of centrifuge to pull the worms out of the castings and the worms and the castings to the screen. So then the worms are used for fishing, for animal feed.
Do they get reintroduced back to?
Some of them do, yes.
Okay.
So the excess gets taken to market. Some of them get
Isn't that traumatic for the animals, though?
Not at all. They're very
so they
versatile.
they double in population every 60 days.
Correct.
So then you only have so many animals for so much volume, right?
Exactly. That's why you have to extract them every so often.
So they make good fishing worms?
Good fishing worms. They have all the essential amino acids. They're complete protein. So for cows, for chickens, in the future for humans, once a yuck factor goes off,
Okay, how did you get into, because before this all came about, you were a worm farmer. How did you get into worm farming?
Well, when I was in college, I read a lot about climate change and overpopulation, and it was kind of a call to action for me personally. So I kind of left school and dived directly into entrepreneurship. I had a farm in Santa Rosa where we farmed different crops and kind of an urban farm. And in the process of that, I said, hey, what's the basic of farming? That's fertilizer. So that led me to become a worm farmer to produce the castings. And so through my ventures, I eventually met Biofiltro, and I saw the amazing things that they were doing and the fact that they were producing these things that I was producing as a byproduct of wastewater treatment. So, I jumped on board, and we were actually going to go locate in Davis, and I did some research, and I said, Fresno's the place to be. So pretty much within 2 weeks.
Pretty much the center of the whole dairy industry is right here. I mean, you got dairies in Tulare County, and you've got some north of us.
Yes, in Hillmar area. A lot of dairies. We can really benefit dairies through the wastewater treatment, but as well as some of the byproducts. There's also a tremendous amount of food processors. Just massive food processors with millions of gallons of flow during peak season.
But of course, the food processing wastewater is certainly different than animal waste.
Yes, it is. It is.
The acids are different.
Correct.
So
it'll be different, but we can treat it no matter what, as long as it's a liquid contaminated with organic material. So the BOD of this stuff coming in can be anywhere from 1,000 to 2,000, but
1,000 to 2,000 what?
Of BOD, biological oxygen demand. It's kind of the indicator that lets you know how much organic material is within the wastewater.
Okay.
But we also treat water that has 27,000, 30,000 BOD. So we can do, that's high strength water right there.
Okay.
And that's coming from a tomato processor.
Okay.
So we can do the high strength, and sewage water is a BOD of 200, 180 to 200.
Okay.
So we have a vast range in which we can operate in.
Have there been any sewage treatment facilities in California that have taken a serious look at this yet?
Yeah, the city of Firebaugh is piloting our project, and they're looking seriously at it. The cities of Kerman, Ridgecrest, Lemoore, Livingston, many of them have approached, and they're kind of observing our pilot project. That's the point of the pilot project, to demonstrate that this system actually works. So they're all observing the technology and looking at it very seriously.
Now, how many municipalities and other folks do you bring in here to show them this technology?
Well, we have this one and the two in Firebaugh, so we kind of bring them to all
But the Firebaugh is practical application because that's actually working on the city's sewage, right?
Well, that's also like this. It's that one's doing 1,000 gallons a day, so that is a small system as well.
Yeah.
It's just demonstrating what's coming in, what's going out, the reductions that we're achieving, and so far they've been fantastic.
Now, the environment that the worms live in, is that habitable for the other insects?
Yes.
And
You'll find roly-polies in there. You'll find a whole range of other insects that will be living
so what's
there.
healthy for them is probably healthy for whatever.
For a lot of beneficial bacteria, because the worms and the bacteria around them actually eat the non-beneficial, like odorous bacteria, E. coli. They feed on these non-beneficial, but around them, the habitat that they have, it's a lot of correct.
They got a pretty ravenous appetite.
Very ravenous appetite. They eat their body weight in a day. So
no kidding.
They're very ravenous.
And do these worms? Do they get really big?
No, I mean it depends. Sometimes they can, but you know, about that long.
4 to 6 inches.
Yeah. No more than 4 inches.
And so, are you able to market the castings?
Yes, that's what we typically do.
So where are the castings, and I know we've already talked about this, but where are the castings going?
The viticulture industry is the biggest consumer of wine because there's flavonoids, there's a lot of benefits. They can also afford it. Right now, it's actually the most expensive fertilizer on the market.
So if a farmer's got some pretty nasty soil, not nasty, but you know, it's not the best soil for growing crops, will this, I assume that this will benefit bad soil and bringing up the quality of the soil. Correct. So that other people they could grow other crops that they weren't able to grow before in the same soil.
True. With the right application, the castings here, it's a humus. It basically is soil, almost like ancient soil, but you're producing it as we speak.
Yeah.
And so when you blend that with compost, you got this perfect mix, and it can help increase water retention. The soil structure is more beneficial for the plant roots, so it can definitely help a lot of the depleted soils that are out here.
So will we see Biofiltro castings available at like Orchard Supply Hardware in 10-gallon bags?
You know, our primary business is wastewater treatment. We do a lot of work third party, so there's many great fertilizer companies that out there already with their own brands that we'll be working with. But
because I can imagine there'll be multiple revenue streams. I mean, you'll be cleaning water for one thing, but you'll also be able to market the castings and perhaps market the animals too.
Exactly. I mean, the business that we are in is the reuse industry.
Yeah.
So we want to extract as many valuable commodities and materials out of this. Right now, much of this wastewater is going into a hole in the ground and contaminating the aquifer. So we're making sure we take those contaminants out and convert them to these beneficial byproducts that society can then use. So that's one of the beautiful things about our technology.
This is really, really fascinating stuff.
We're very excited about it. We're very happy to be here. And yeah, we hope to just continue to do good work. And anyone who's interested in our technology, they come to us. We do a free proposal for them. We understand their situation. And if we can be of help, we definitely.
So it's Biofiltro. We can probably go on the internet, go to, there it is right there, www.biofiltro.com.
Correct.
And that will lead them to either be able to talk to somebody or see what you supply?
Correct. You'll see some videos on our past experience. You'll get some information about what we do and what we have done, and you'll get you'll see some information to contact us here at the Wet Center at Fresno State.
Yeah. And how long have you been associated with the Wet Center?
About 8 months now.
About 8 months,
and
so not that long.
Both, we've only been here for 8 months, and we've been moving pretty quickly, but the Wet Center and Fresno State, as well as the Fresno Economic Development Corporation, they've all been of huge assistance.
Yeah, I can imagine that this is very exciting for the ag industry, because this is able to clean the water and have reapplication for it.
Yes, and the community has recognized that, and they've been very responsive to us, so the people that are here are just fantastic.
All right, what did you major in when you were going to school?
I was political science.
Really?
I'm a history buff, but I had that entrepreneurial bug in me, and like I said, we need to do a lot to kind of fix the world's problems.
So when you're rich and famous, are you going to still talk to us?
Oh, of course.
Well, this has been most fascinating. Sanjur Taromi, thank you so much for being on the Valley today. And Biofiltro is a very exciting technology. I can see great application for this and a bright future for a young rising star. Sanjur Taromi on the Valley today. Thank you so much for being with us. And the Valley today is a public service presentation of this great TV station. Thanks for watching, and have a great day.